This webcast, we assume that you have some experience with Java Enterprise Edition development, that you have some experience with HTML and JavaScript, and we will be using the following tools. We will be using NetBeans IDE for Java EE version 7.3.1 and GlassFish Server Open Source Edition 4.0. Specifically, what we assume that you know about Enterprise Edition by this time is that you know how to create web applications and how to deploy them to GlassFish Server. We're not going to touch any servlets or JSPs or JSS for that matter. That's why we are asking for basic HTML and JavaScript knowledge. Java Enterprise 7 is comprised of three primary themes where it has been developed on. The focus was for this release on developer productivity, HTML5 support, and meeting enterprise demands. The developer productivity, we made Java EE7 easier and faster to develop on. There's more annotated POJOs for configuration, less boilerplate code, more cohesive and integrated platform. This allows developers to increase their productivity. On the HTML5, we introduced WebSockets, JSON support, the Servlet 3.1 non-blocking I/O, and RESTful clients and servers for the web platform. And finally, meeting the enterprise demands on Java EE7 was introduced introducing the batch application API, concurrency APIs, and we simplified a lot of the JMS code and others. So building Java EE7 for next generation applications introduces two new concepts and two new technologies, WebSockets and JSON. WebSockets is part of the HTML5 initiative, and JSON is a representation notation for objects that is widely used on JavaScript. This technology has been increasingly popular, so right now it's part of Java EE7. WebSockets is a new initiative, so it has been incorporated as well. The idea behind this is to reduce the response time for low latency data exchange using WebSockets, simplify data parsing for portable applications with standard JSON support, and we also added for the HTML5 part asynchronous, scalable, high-performance RESTful services. So what is WebSockets exactly? WebSockets, as I said, is part of the HTML5 initiative. They are used for real-time full duplex communication. You use just one channel of communication to exchange data between the server and your browser or device. For this, servers must support WebSockets connections, and clients must provide WebSocket support. WebSocket is a brand new protocol that allows you to exchange data in real time from the server to the client and from the client to the server. So they both must support them in order to work. The good news is that most modern web browsers already support WebSockets, as well as many of your devices that you have already support WebSockets. WebSockets can be used for mostly game development, notification, communication, this means chat, multimedia streaming, and server push, replacing what has been known as long polling and comment. This is a more elegant solution to any server push scenario. That's why you always want to use WebSockets if possible. And with any further explanation, let's go to the demo. I will be showcasing you an application that was showcased first in the Java magazine for this edition, for May-June edition. So let me show you. This is the application we will be developing today. It's a sticker book application. You have stickers on your left, you have a canvas to your right, and you can drag these stickers to the canvas, and then they stay there. They are drawn. Whenever you drop a sticker, a WebSocket message is sent to the server receives it, and it is propagated to all your browsers. So as you can see, it's a collaborative sticker book. If I take this astronaut over here and I drag it here, you can see that it is rendered on the other browser. So all this communication is made using WebSockets. The messages sent from the browser to the server is achieved using JSON. So instead of sending messages or anywhere representation of the objects, you just send the JSON representation, and yeah, that gets propagated. The JSON objects are sent back to clients also from the WebSocket. So all data exchange is using JSON. Before we dive into this, I want to show you two useful web pages that you can use in order to know if you cannot use WebSockets or not. The first one is websocket.org. As you can see, here's an echo test inside the site where you can actually test your web browser WebSocket capabilities. So you can see here if it works. For a more detailed chart, there's this site, caniuse.com/WebSockets. As you can see the versions of the browsers that already support WebSockets and which one doesn't. This one key part, if you are going to use WebSockets, to keep in mind that it is not entirely supported on all the browsers that you're going to target. So you should always mention that you require a specific browser version at least. With time, this won't be required, I hope, since everyone will be able to be supporting WebSockets. So let's begin. So the first thing you have to do is open your NetBeans, IDE. So let me move this over here. And then we are going to create a new project. I'm going to create a Java web application, so I select this from the categories. From projects, I select web application. Then I have to name this application sticker story. Let's call it that way. So let's move to next. I am going to target my GlassFish server, and I am going to target the Java EE7 version. In order to have these options, you have to already configure your GlassFish server. And finally, I am not going to use any framework at all. My front end will be HTML. My backend will be a WebSocket, so I don't need any. And then I am presented with this. A simple web application created using NetBeans just includes the index.html file. And as you can see, there are no Java files included, anything that kind. We have the JDK 1.7, which we will be using, the GlassFish server, YARS, and just simple configuration files. Since this is Java E7, you can see that as with E6, there's no WebXML file, just the beans to enable a CDI injection, but there's really nothing else created. So let's begin by creating our WebSocket class. So the first thing we have to do is create a new Java class. This class, we will be calling it the WebSocket. So let me see. It's a story WebSocket. Let's call it that way. And let's give it a package that makes sense. Or .sticker.websocket. Let's click Finish, and as you can see, I have a simple class. WebSockets in E7 are simple classes that are configured using annotations, and it's really simple just to incorporate them in your applications. So to create this, to make a WebSocket out of this class, you have to just add the server endpoint annotation. Endpoint. That's why. As you can see, I get included my Java WebSocket server endpoint annotation here, and this requires value property, which is the path that will be mapped to this server endpoint. So let me copy that here. This will be the path that I will be using. And this actually configures this class for being a WebSocket. we have to add now the methods that will be handled by this WebSocket. So I have annotations for that. I need to set to create a method and annotate it in order to tell the server that it's going to be a WebSocket method. So I have lifecycle methods for this. So I have a method whenever someone connects. So let's call it on open. Whenever someone connects, I receive the session used. So let's put it here. I fixed my imports. No, that wasn't the import that I needed. It's the WebSocket one. So the session from WebSockets. I want a method whenever I receive a message on message and the message. And I want a method whenever the user disconnects. And I also receive the session that just disconnected. So as I said, you can have any number of methods, but you have to configure them using annotations. Right now, this class doesn't know exactly which one to call on these events, so I have to tell it, use it annotations. The annotations I am using here is on open for whenever someone connects, on message, whenever someone sends a message, and on close, whenever someone closes the connection. So this is actually the simplest WebSocket you will ever see. Whenever you have whenever someone connects, this method will be called, the onOpen method. Whenever someone sends a message, this method will be called, the onMessage. And finally, whenever someone closes the connection, the onClose method will be called. So right now you see that I have here, I receive strings as the message. This is a part of the WebSocket protocol. You can only send two types of messages in WebSockets. You can either send strings or send binary data. JSON is a string representation of an object, so it makes sense to have strings here. But it will be far more elegant to receive an object directly. So I make the conversion from the JSON somewhere else, and here I handle that object directly. That object, I wanted to call it a sticker instead. So I will receive stickers, and I will be sending stickers. So I receive a sticker that has been converted, and I will actually handle this message here and send the stickers back. So let's create our sticker class. The sticker class should contain the properties that a sticker has. So I know that I want the coordinates, where that sticker lies. So whenever someone drops a sticker on the screen, I know where it has been dropped. And I want as well the actual sticker that has been dragged over. So here I have it, the coordinates and the sticker. So let's use the auto-completion feature of NetBeans to create the getters and setters. And that's it. A simple class with getters and setters. So right now I am receiving that sticker object, which has been parsed somewhere else. We will add the parsing later, and then I want to send this sticker object to all the connected users. As you remember, whenever I drag a sticker to a canvas, that sticker is sent to all the connected users. So I want these sessions to be stored somewhere. So one way to do it, a really simple, quick, and easy way to do it, is to add this. I add a collection of sessions, in this case a set, where I will store all the sessions that are connected to this WebSocket. I make it static because I don't know the life cycle of this WebSocket object. The server may reuse it or may create new instances whenever a user connects. So instead of using CDI or any other complicated features, I will just create a simple, plain, and static final variable that will be shared among all the instances of this class. Now, whenever someone connects, I will do just a sessions.add session. And whenever someone disconnects, I will do session.remove sessions.remove session. And this actually does the trick. Whenever someone connects, it is added to the sessions set. Whenever someone disconnects, it is removed from it. Now, we want to send this sticker to everyone. So we have to iterate the session set. So for every session, sessions. For sake of not confusing us anymore, I will add here instead open session or connected session, any will do. And I will send now the sticker open session dot get basic remote dot send object. And I will send this sticker object. This throws an exception. I will use the autocomplete to just surround everything with a try catch. This looks a little overly complicated, so I will use Java 7 syntax to simplify the catch clause. This way it looks a little nicer, although it's still not really that nice, but it works. So right now I am sending the object that I received to all the connected sessions, and this object will be, and all the connected sessions will be added whenever they connect and removed whenever they disconnect. I mentioned that we have to serialize this sticker object and deserialize it somewhere, because right now the application doesn't know that it's going to receive a sticker object that is going to be a JSON representation. So we have to add that. For that, we will use another feature of WebSockets, which is called the encoders and decoders. Encoders encode the objects into a string or a binary data whenever you send the object. And a decoder decodes the binary data or the text data into your objects that you receive. So for that, we have to change the declaration of our server endpoint annotation. Why? Because we need to specify that we are going to use a decoder and encoder. So it changed to something like this. We specified in the encoders and decoders we're going to use in this WebSocket. So here I have a sticker encoder and sticker decoder class being added. I don't have those. I haven't created those yet, so I have this compilation error. So that's what I will do right now: create encoders and decoders. So let's create encoder. I just right-click, create a Java class, and create a sticker encoder, and I will create the decoder. Well, we are here, sticker decoder. So I have both right now. Having both isn't enough yet because they have to implement certain interfaces in order to work. So let's implement those interfaces. The interfaces you have to implement is the encoder dot text stream and say that you're going to use sticker objects. For the encoder, you have to implement this interface. I've resolved my imports, and then I just implement the missing methods. There we go. So now I have an encoder, and as you can see, well, whenever this refreshes, here, this error has gone away. So I'll do the same here. I will implement for the decoder a class inside the decoders. Decoders dot text string, and I will say that it decodes stickers. So I will add the import, and then I will implement all abstract methods. Now my error should be gone. Perfect. This means that it is configured correctly, but still we need to work on the encoder and decoder logic. For this, we will focus only on the JSON API. So let's begin with the encoder. The encoder will encode sticker objects into their string representations. We know that we are going to send a string because we are using the text string encoder. If we were going to send binary, we will use the binary string, like here. So we will remove all the code that has been created for us because we don't want to throw anything. Encoders have an init and destroy method that you can use to configure your encoder in case you need it. Also to initialize resources and destroy those resources if you also need it. But the real core of the sticker encoder class is the encode method. So it receives a sticker and the writer we're going to write to. So I just rename them to make them simpler. So I want to write a sticker object using my JSON API. So one way to do it is using the JSON, a JSON representation of the object. To do so, I want a JSON object to be created. So I have the JSON object, which is the JSON representation of the sticker. So I create that. So the imports. And I want to create this JSON object using the JSON API from Java E7. To do so, I have to create an object builder. The JSON API in E7 uses the builder pattern a lot. So you have to create a builder from your JSON utility class. You can also use JSON provider for this. And then you have to add the properties and finally build the object. So let's add a property. Let me fix the import. There it goes. Let me add a property. We will add something arbitrary. Let's add an action. So you have to add properties to this JSON representation. So let's say that I add this property, which is actually an arbitrary property just to show you how easy it is to just add properties to this object. So I add this property, the action that has been executed is a sticker, and I say, okay, by default it's just an add. But let's add some other properties that actually comes from the sticker object over here. What if I send first the coordinates? I will send the x coordinate, sticker get x, and then I will add the y coordinate with the sticker dot get y. Finally, you remember we added we have also the name of the sticker, the actual image that has been added. So I want that as well. I will call that as the sticker property inside of the sticker object. And let's see what's the name. Get image, of course. And finally, I want to build this object. So I build, and this actually returns the JSON object that I want. So you can see that right now I don't have any compilation errors, anything of that kind. It has been created with these properties. Now, this JSON object is the JSON representation of what the sticker is. I want to send that as text using the writer. So to do so, I have to create a JSON writer. So let's create a JSON writer, which is an auto-closable class, by the way. So you can take advantage of the Java 7 syntax equals JSON.create writer, and I give it the underlying writer because it works much the same as any other IO class. And I just do a JSON writer dot write object, JSON sticker. That actually does it. This will encode the sticker object into a JSON object and then write that JSON object as a string on the writer that has been provided by the JSON, by the WebSocket API of encoders. So this way you solve the problem of sending from the WebSocket class, sending sticker objects. Now we need the other part of the puzzle, which is receiving sticker objects. Let's create a decoder for that. We have here the decoder that I previously created, and I just have to fill in the blanks. So let's remove this, delete, destroy method, okay? So we can see that here we'll have to return a sticker. So let's create that sticker object first. Sticker equals new sticker, and let's just return this. Return a sticker. So here I received the reader that I have to use to read whatever the client sent to me in the WebSocket. So the WebSocket actually received text. So we have that text inside here. So, and I know that that text is a JSON object. So actually I need to decode it. And I will do that using the JSON API again. So I will now create a JSON reader using our Java E7 syntax. I can actually use that. JSON reader equals JSON.create reader. And you can see that I can receive the reader from the parameter. And this way I have a nice JSON reader included here. Now, using this reader, I can read an object. So I use JSON reader dot read, and you can see here I can read the object. I know this object is the JSON sticker, so I will assign it. It's an object, JSON sticker. And now from this JSON sticker object, I can actually read properties and set them into my sticker object. So I will do sticker.setX, and I will get the X coordinate from the JSON sticker object. So I will get int, and the property I want to get is the X coordinate. I will do the same for the Y coordinate. And finally, I want to set the actual image. So set image, JSON sticker, dot get string, and I know the image is actually named as a sticker in the JSON class. This is done on purpose to actually show you that your JSON representation of the object doesn't need to be named exactly as your properties in your Java objects. They can be rewritten at any time. So here in this case, I do the inverse operation that I did on the Encoder. And that's it practically. You created a sticker object that you will return, and you return that sticker object to your WebSocket. This actually completes your server-side part of this tutorial. We will focus now on the client side, which is an HTML5 page that includes a little of JavaScript code behind to actually handle all the actions that are executed on the HTML page. As you can see, to create a WebSocket, you just have to create a class, annotate it using the server endpoint annotation, add your methods, annotate them to make them react to events on your WebSocket, add your logic, and if you are going to receive something that is not a string or a binary data, you have to add the decoder and encoders and implement those in order to receive any kind of data. So let's move on to the HTML side of this application. So if you see the HTML, it's just a plain HTML5. It doesn't have anything special or out of the ordinary. You have tags, HTML tags, and that's the way we're going to keep it. We're not going to add any Java code here, just plain JavaScript and HTML. So For this tutorial, we have also a resources folder that I have outside and that we provide as well, which contains all the resources that we are going to be used in the application, meaning primarily style sheets here, images here and here. You can actually have your background images and all the stickers that you just saw. We're not going to create those here. They are already provided. And also a starting JavaScript code that contains most of the things that you need to actually draw the canvas and making drag and drops, which is kind of out of scope here because drag and drop is more of a JavaScript thing than a Java thing or WebSocket thing. So we are just going to focus on the contents of the HTML file and the JavaScript that is required to use WebSockets. So first, we have to give a little shape to this HTML5. So first things first, let's add the head stuff here, which contains the title, and I will link the resources, the story page JavaScript, and the style CSS. So I have my style sheet and my JavaScript file added here. Using HTML5 syntax, I will create the web page. So I will add a header object, well, header tag with some headers here. I will create a nav element, which I won't be using for navigation. I will be using it for some instructions. So I create my nav element. And the ever increasing aside element as well, which will be my sidebar, which I know I have here, the sidebar with the stickers. So I want this sidebar, so I just create an aside element. I will put an H2 stickers, and then I will just add a div as my sticker container, so I can actually have my stickers inside. Now, what's a sticker? You may ask, how did I make them draggable and all that stuff? Well, it is not rocket science, as they say. It's just a simple image element. You have to add the source. So I know the source already, which is the resources folder. I know that they are stickers. And then I will just say the alien. So with this, if I run the application, I will have just a plain one sticker on the left. Let me drag because it has been opened here. This is what I get. You can see the layout taking a little shape right now. So that's the idea. You see the layout flowing. Then I will add the content. So at the content, I know I want a canvas that I have to use to actually draw something. I will remove this. I will add this layer so you can actually see just the canvas itself. And the background image that I am going to use for the canvas. I don't want to draw this because it's going to be drawn using JavaScript, so I just say it's plain none. I want it to be loaded, and I want to, once it's loaded, to use it to paint this thing. Finally, the footer and a debugging div, which is really cool. You will see it in action. So all this code is just a simple footer element and a div containing a log element. So if I go back to if I run again my application and I see the results, we'll see actually what happens. Now I have the sticker, I have the canvas here, and I have this log button which actually opens the log, which I will be using for debugging purposes. But I cannot drag this guy yet. I have to add the JavaScript required for that. That is really simple, actually. So to add drag capabilities to your page, you have to your elements. You have to add a couple of properties. The first one is draggable. You have to say that it's draggable. The second one is a couple of events, of JavaScript events. So the first one is on drag start. What I'm going to do whenever the drag starts, well, I will call the drag function on JavaScript. So I will say, okay, just call that thing. And whenever well, that's pretty much it actually. This should allow me to drag the object. So let's go here, let's refresh it, and I should be able to drag. Yes, I am able to drag, but I am not able to drop. That's actually correct. But now I can drag the object, but that doesn't mean I can drop it, because there's nowhere to be where I can drop this object. I have to add some JavaScript callbacks, well, functions here, events on the canvas. So the first event I want on the canvas, since this will be handling the drops and the dragovers, I want the on dragover event. This tells the browser that this element may accept drops or may not, and it has to validate them. And finally, the on drop. Whenever someone actually drops something on this element, we want to call this function. So let's see how it looks like right now. Let's run it again. And then let's see how it fares. You can see that now I can drag. I have the icon that allows me to drop, and then if I drop, we actually get something in the log, which means that actually we're doing it right. There's some kind of action going down here. In HTML5, we can also set arbitrary data properties to your tags attributes. So we can set data attributes that contains some data that we want to get in our JavaScript code. In this case, I want to tell the JavaScript code what is the name of the actual dragged image that I have, the file name, just this part over here. So I just added a sticker to it. So let's see. Right now, if I run it again, you will see that actually nothing really much changed. But if you open the log, you will notice that now it says that you have dragged the sticker alien.png. Why? Because we are providing that right now. But everything is done on the JavaScript side. So we have the drag, the load drop, and the drop functions. These three are the ones that are handling the drag and drops in JavaScript. So let's go to that JavaScript file. Here you will find that we have implemented already the drag, the drop, and the allow drop. This will actually allow the drop. This will handle the logic behind the drop itself, and this will handle the creation of the object that has been dragged. You can find more information on this on any JavaScript tutorial about drag and drops. What we really want here is to actually send this object to our WebSocket. So right now I prepared it with this socket variable here, but it is not initialized anywhere. Actually, if you search for usages, you won't find it that it is being used anywhere. So let's initialize that socket. So I initialize it in JavaScript using the WebSocket object provided. So let me just copy from here. Faster that way. So a WebSocket is created using the new WebSocket object, and I have to give it an absolute URL to the WebSocket that I am connecting to. This is really important in JavaScript. You have to use the absolute URL. Why? Because you change the protocol. So instead of using HTTP, you're using WS, or WSS for Secure Socket Layer, WebSockets, and then to say the host, the context path, and then finally the WebSocket path. So we have the host, the context path, and the WebSocket path. So you have the complete URL, the absolute URL. So this creates the WebSocket. So now I know that that will be created. Let's see. Let's refresh here. This is not the one. This is the one. Yes. So as you can see, we have here the application. Nothing really changed. And if you open your debug tools, there should be no errors since now it's connecting. But there is no actual problems or anything. It just connected to this WebSocket and leave the WebSocket open. So it will be open since for all the time that I have that browser open. If I close the browser, the WebSocket connection will be closed. So how do I send objects using the WebSocket? Then I have to add some code somewhere, right? I know whenever someone drops something on the canvas, whenever I do this drop, the canvas invokes the onDrop method. So let's go to that one. Drop here. Now, whenever you drop, as you can see, we already create a JavaScript object with everything, with the action, with the X coordinate, the Y coordinate, the sticker, and we just log it that we are going to send it, but we do not actually send that. So to send it, we actually do the socket.send. We use the socket we created up here, and we call the send method with a string representation of the object. So I use the same JSON stringify. And this actually sends this object using the WebSocket. Just as simple as that. If I refresh and I drag, you can see no errors, and it is being received by the WebSocket. Now, what happens on the other side? What happens if the WebSocket sends something to this client? Well, we have to add a callback using the ever so common event syntax from JavaScript. So I know that there's an onMessage event. So whenever there's a message received, I call a function, a JavaScript function. So I assign that JavaScript function to be the handler of the onMessage event. Now I have to create a function, so it's really simple. It's created on socket message, and I know I'll receive an event. And then let's just write the contents of that function. So first things first, I know that I received a sticker, and I will use JSON .parse event.data. So whenever I received a WebSocket message from the server, the message itself is inside the data attribute in my event object. So with this, they receive the sticker gets parsed. Then I will add this code over here to actually draw it. So I create an image. I assign an onload callback function to that image. And finally, I assign the source from the received sticker. This might look a lot of code, but it's mostly related to drawing an image on your canvas. You have to get the canvas, you have to get the 2D context for that canvas, and then draw the image in the X and Y position received from your received sticker JSON object. And finally, you have to assign the image that you want to load. So let's now test the application. It should be working right now, everything. Let's refresh it, drag and drop. And see, now it's there. What happens is not that I drop it and it gets run. What happens is I drop it, I send the message, And then the server sends this message back to me, and then I draw. Because I do not draw until I know that my sticker was received from the server. And I know it has been received because I received an acknowledged message. So let's see if now it works on top Windows. Drag it here. Well, I should have dragged it here. And you see? Here I have it updated. This actually finishes this part of the tutorial and demo. As you can see, there's a lot of JavaScript code involved and a lot of Java code behind, but there's really not much complication. Everything is separated. You have decoders, encoders, a WebSocket object, sticker object that you're going to send, and the HTML part is just plain HTML. It doesn't have anywhere Java code inside here. This allows you to write really scalable applications because your WebSockets are agnostic of really what's the view you're using. So let's move back to our slide deck. You can download the Java EE7 SDK from oracle.com/JavaEE. The reference implementation for GlassFish, well, for Java EE7 right now is GlassFish 4.0 for the full platform of web profile development. You can find that on glassfish.org. Please get involved in the process of making the future Java. Java EE7 is an effort from you and for you. It is created by the community, and the community is involved, is highly involved in the development process of this platform. It ensures that we have platform completeness, modernization, innovation, that we focus on the developer productivity, and we have an open and transparent evolution, active community involvement, quality and security. Just go to your local Java user group and ask them if you want actually to adopt a JSR, and you can be part of the process of creating the next Java 8 or the next Java 9 or whatever. I highly recommend you to go there and get really involved in this because you can make a difference. If you see that there's a feature lacking or that you want something there, you can actually do that. So get involved in this process. You can find other resources about Java EE7 on the Oracle Learning Library site. We offer free demonstrations and tutorials on most of the topics that you have seen here. Actually, this demo itself is part of an OB on Oracle by example material in the Oracle Learning Library site. You can find it if you just search for WebSockets there, and you will see the entire tutorial describing all what I've just shown you here. Well, from my part, I think that's all. Peter, on to you now.
Thank you, Eduardo. So we're just about out of time, and I would like to mention that if you're interested in playing back this webcast or accessing other free learning content, go to the Oracle Learning Library. This concludes our webcast. Thank you all for attending, and have a great day.